Now that we've got a little bit of a feel for what a function is, we want to talk about how do I actually indicate now it's a function in a more relatively recognizable way. And then we're going to continue back with our lines and talk about linear functions. So we're going to first go through this function notation, and then we'll go through the linear function and also the constant function, which is just a horizontal line. So first and foremost, to indicate that something is a function, and again, y is our output, x is our input, so you can think of y as depending on x, we're going to use this notation y equals f of x. So the reason we do this is the f is basically signifying it's a function, but it's also just a letter to name it. This x is our input, so that's going to be input to the function, and the output are these y values. So our x is that input, which is our domain. It is also called our independent variable, so there's no restrictions on it. But we're going to have some kind of expression that's going to tell us what the y value has to equal. So the y is an output, but a dependent variable. Let's connect this with stuff that we've already done before. We've seen that a line is going to pass our vertical line test. So if I have the line y equals 2x minus 3, this is a function. We can write really a ton of different things to indicate it. So instead of writing y, I would just use the notation f of x is equal to 2x minus 3. And so if I plug in x equals 1, that would tell me what my output value is. But really, you don't need to call this f. You can call it g of x equals 2x minus 3. Or you can say h of x equals 2x minus 3. All of these indicate this is a function of x. The letter that you attach out here up front really is just naming the functions. So this way, if we're working with multiple, we'll know kind of the distinction between those. So let's get some practice. So we're going to let f of x equal x squared plus 2x. Based on that, we want to find the following things. So again, we're really just figuring out what is the y value corresponding to input x. So in the same manner that we found y values before, anywhere we see an x, it's going to get replaced by whatever we have here. So this x corresponds to both of these. I'm going to replace the x by whatever expression we have on the inside. So for the very first one, if I want to find f of 4, anywhere I see an x, it's going to get replaced by that expression on the inside, which is just a 4. So I have x squared, that's going to become 4 squared. And then I'm going to add 2 times x, so we have 2 times 4. Now going through our order of operations, 4 squared is 16, and then 2 times 4 is 8. So if we add these together, we get 24. So this is our function evaluated at 4. And then just as a note, what this means is when your input is 4, your y value corresponding to it is 24. So this is a point on the graph. And so we do exactly the same thing for the next problem. We get the variable squared plus 2 times the variable. And this time our input is -1. So we're going to have -1 squared plus 2 times -1. So be very careful. A lot of times what will happen is people will just write -1 squared, and that's not right. When you write this, it means -1 times 1 squared. So you're going to get something that's a little bit different. So I'm taking that entire input and squaring it. So as a result, this really becomes +1. And then 2 times -1 is -2. So the output for here is -1. So our input is -1. Our output happens to be exactly the same thing. Again, this would be a point on the graph. Let's make it a little bit more complicated. We're going to evaluate f at x plus 1. So again, off to the side, just to refresh on what this function is, it's x squared plus 2x. So when I want to evaluate this at the full expression, I'm going to get the full expression squared plus 2 times the expression. So this one's going to be a lot more complicated. We get the expression squared plus 2 times the expression. So we're going to have to take x plus 1 and square it. And so remember, when you're doing something squared, it just means that thing times itself. So I'm going to actually do that off to the side. X plus 1 squared is x plus 1 times x plus 1. Right? And the method we have for actually going through this is we want to FOIL. So remember, F stands for the first terms. So we would multiply the first terms. So that gives us x times x, which is x squared. The O stands for the outer terms. So we have 1 times x, which just gives us x. The I is the inner terms. So that's positive 1 and x. Multiplying those gives us x again. And then L stands for the last. So we get 1 times 1, which just gives us 1. So condensing these, x plus x is 2x. So it simplifies to x squared plus 2x plus 1. So really this first piece simplifies to the following. And then for the second piece, we have to distribute that 2 to both pieces. So that gives us 2x plus 2. And then combining our like terms, we have 2x and another 2x. We have 1 and 2. This is equal to x squared plus 4x plus 3. So one more example before we go on to linear functions. We want to write the equation using function notation. And so again, that means we want to write this in the form y equals f of x. So we really have some expression here at the end. So all I want to do in this is I want to solve for my y value. So we've got negative 2x plus 5y equals 9, and I want to solve for y. So we'll go ahead and bring the 2x to the other side, and that gives us 5y is equal to 2x plus 9. And then we go ahead and divide both sides by 5, and that gives us y is equal to 2 over 5x plus 9 over 5. And so I have y isolated. The last thing we do is we replace y by this notation f of x. So this function is f of x equals 2/5 x plus 9/5. So last but not least, we're going to now tie this back together with our lines. A line is a function. So when we say a linear function, it's really just a function in the form where we have that function notation, f of x equals mx plus b. So m and b are just real numbers. Remember, m is representing the slope and b is that y-intercept. For this specific one, we want to make sure that the value of our slope is not 0. Otherwise, that's really our constant function. So we make a distinction between those two. And so thinking back to finding our domain, for a line, there's no problematic values. I'm never going to divide by 0. I'm not dealing with square roots, so I have no issues. So really the domain and range for our linear functions are both going to be all real numbers, unless there's some kind of specification otherwise. So when we start talking about piecewise functions later, maybe we're only going to take part of the line, or we're restricting it to like positive numbers. The constant function is also a type of line, but we make this distinction because it's just a horizontal line. And really, the input for this is interesting, or the overall expression, because no matter what you input, the output is always going to be some value of b, which is just a constant. So your domain, you can input whatever you want, but you're only going to get a single y value in the end. So the range is just going to be a single value. So let's just do 2 quick examples. We're going to graph each function, and then we're going to state the domain and range in interval notation. And so for our very first one, we have the line f of x equals negative 2x plus 5. So here, our slope is negative 2, and our value of b is 5, which is our y-intercept. So let's start just by graphing this before we go ahead and find the domain and range. So I'm going to go up at least 5 in each direction. So remember, we start by plotting our y-intercept, which is up here at positive 5. And then our slope is negative 2, so that means we go down to over 1 to get another point on our graph. Then I can do it again. We go down to over 1, and here is another point on our graph. So this is the point 0, 5. This is the point 1, 3. This is the point 2, 1. And then we go ahead and just connect our dots. And this is the graph of our function f of x equals negative 2x plus 5. Okay. So looking at our line, it continues on forever in each direction. Our domain is anything we want, so all real numbers. And our range is going to be exactly the same thing. Now for our last example, we have g of x is equal to negative 2. So here, I have no x values on the right-hand side of my equation. So no matter what I input, my y value is always going to be negative 2. So let's just do a couple marks in each direction. But if your x value, if you want to make a table of x and y values, when you input 0, your y value is negative 2. When you input 1, your y value is negative 2. When you input 2, same thing. No matter what you input, the y value is always going to be negative 2. So we just have a horizontal line. And this is the graph of g of x. So our domain is still anything we want, but our range is just a single value. So again, we're just going to have y being negative 2, and I want to include it in that set notation because it's at interval. We don't really have an interval here because it's a single value. So this will be our proper notation.